Okay, here's the next version of our, final exam open-ended questions. All right, you're going to pretty much see these on your final exam after the multiple choice sections. So in this is a 13-point problem because there's multiple things that you are expected to do. All right, we've done this before. This is actually one of the problems straight off of our midterm. So for this, all right, you have to do 1 point for each label, all right, on the free body diagram, 2 points for showing work and answer for FG, which is weight, and FF. All right. Hopefully you remember it. If you don't, okay, I'll wind up actually maybe throwing that equation up on the board, but hopefully we do remember that equation. So first thing we're going to need to do here is, all right, find the weight of the object. So Fg is m times g. The mass of this thing is 10 kilograms. We use 10 for gravity. All right, multiply those out. You're going to get 100 newtons. Okay, so this would be 0.1, 0.2. All right. Now, we are going to label these things on our free body diagram. Fg, 100, and Fn, which is our normal force on a flat surface, it is going to be equal to the weight or gravitational force of the object. Okay, I'm going to show that they're equal here. Boom, boom. All right, 1, 2, this would be points 3 and 4. Now, what else do I do? Now, you need to, it says 2 points each, 1, 2, for showing work and answer for weight. And then we need to do the same thing for the frictional force. The friction force triangle is here. We're looking for FF. If they're next to each other, you're going to take the coefficient of friction, which is the mu here, all right, as 0.6 times our normal force. So in order to figure out normal force, you had to do mass, all right, times gravity. Got that, draw it in, boom, this is going to be the same value going up. So the frictional force is the coefficient of friction times the normal force. Coefficient of friction was this 0.6 times 100 as our normal force, and you're going to get a value here of 60 newtons. So that is worth an additional 2 points. This was 0.4, so this is 0.5, this is 0.6, and we want to draw this in. All right, how are we going to know which direction to draw this friction force in? Well, friction always goes opposite the direction of motion. So if we kind of look here, right, if the block is pulled to the right, okay, if it's getting pulled to the right, friction would be in the opposite direction. So friction we're going to draw to the left, so we're going to draw an arrow to the left, labeling it friction force, 60 newtons. Okay, part B says your applied force, all right, we're pushing this or pulling this thing to the right by 170 Newton force. So we're going to draw that in. Okay, draw the friction force. That was our 1/6. That was our 7th point. Drawing this in is our 8th point. 170. Is it? All right, we got that answer. We got that from here. Now the next thing is pretty much going to say, hey, what's the net force? Well, you'd be like, well, you may see this equation. You'd be like, well, net force is mass times acceleration. Well, we have the mass. We don't have acceleration. There's a reason why you're not using that yet. All right, guys, when we had done free body diagrams, you should be able to look at a free body diagram, okay, and determine and balance out the forces. Okay, opposite directions, what do you do with them? All right, we subtract. So you got 100 up, 100 down, they balance out. All right, essentially cancel each other out. So you have 170 to the right, 60 to the left. What do you do? If they're in opposite directions, do you add or subtract them? Subtract. All right, and it literally kind of says it right here. 1 point, show the subtraction with the answer, unit, and direction. Okay, so we're not doing the top and bottom, so we're doing literally All right, to find our F net here, we're going to do 170 minus 60, which is going to give us 110 newtons. In which direction? Well, the right side force was larger, so the net force will be to the same direction. Okay, that is another big concept. Net force and acceleration, they're in the same direction as well. So once you've got that, it's going to tell you to solve for acceleration. We cover up A in the triangle, and we're going to do net force divided by the mass. Our net force was 110. To the right, the mass was from the top of the problem of 10 kilograms. 110 divided by 10 is going to give us 11. All right, so there's our show the work. All right, I believe this was our, whatever we had, 8th point. This right here was our 9th point. Show the work as our 10th. Get the correct answer as our 11th point. The correct unit for acceleration, it is meters per second squared. And the correct direction. All right, I'm pointing it out like this, guys. So if you don't get the full thing, you can get some partial credit here. All right. So the first thing you're going to need to do, mass times gravity. All right, get that answer. Draw it down, draw it up. Take the upward force times the coefficient which you are given here. All right, get that number, which is going to be your friction force. Draw it left. Part B, it will tell you what to draw to the right. Then you subtract, get that value. Take that value, divide it by the mass. All right, and it's going to be whatever the number is, meters per second squared, and then whatever direction the most piece is. Now, in this next piece, or this next part here, all right, we are looking to solve for something. What do we got? Fighter jet catapulted off an aircraft carrier from rest to 80 meters per second. The aircraft carrier deck is 100 meters long. All right, it is 100 meters long. So what are we doing on this one? So on this one, again, what you're going to need to do is show everything. All your given variables, okay, what you're looking for, the equation we're going to use, and the work. So let's see, what do we got? All right, from rest means your initial velocity is 0. You get up to this speed. This speed is your final velocity, is 80 meters per second. The aircraft carrier deck is 100 meters long. So D is 100 meters here. Then it asks you what is the acceleration. So your acceleration is your question mark. Now, there are a total of 5 potential variables: VF, VI, acceleration, time, and distance. Those are the 5 possible. Which one of those 5 possible letters is not listed anywhere here? Right? Which one of the 5 possible values is not listed here? Letters. All right, we have VI, VF, A, and D. Which one are we missing? T. So the easiest way to figure out which equation to use is which equation doesn't have T in it. This does, this does, this does, this does not. So because this one doesn't, it will have all the variables that you have, all right, or looking for without any extra things or missing stuff. All right, you could just be like, okay, find the equation that just has all of these. Where you may be like, well, it has VF, VI, and A. I'm going to use this, and then all of a sudden you're like, oh crap, I messed up. I don't have D. There's a T. All right, this is a quicker way. You know, if you want to go the other way, that's fine. This is the way it works best for me. All right, then you're going to write your equation that you need to use. VF squared is equal to VI squared plus 2 times A times D. VF is going to be 80. You must square it. VI is 0. Square it. Bring down the plus sign. 2 times a. A is our question mark, so we leave it as our variable. And then d is 100. All right. Now, all of this is together. We can't do anything to that. That needs to stay together. So in your calculators, 80 squared, 6,400, 0 squared, cancels out. 2 times 100 is 200, and it's 200a. This is 200 times a. It's 200a. You cannot just subtract 200 from the other side. All right. It is together with it, so you must divide out to get acceleration by itself. Boom, 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 boom. And then you come out with okay, so we get a 1 point, 2 points, 3 points, 4. If you did not do anything besides that, you would get 4 out of the total points. All right, but if you can figure that out, you should be able to figure out the other equation. You write the equation, that's your 5th point. If you don't know what to do from there, right, you get 5 points out of it. But like, why stop there, right? Put in this stuff. All right, 6, show this portion, right? 7, then I can do a square or something, and I can do multiply something. All right, and then when you get that, you can also divide something. So here's our 7th point, and then our 8th and 9th point here. Correct answer. All right, the magnitude and the correct unit. Anything you guys miss, you can always come back to. All right, on the video. So we're going to move to number 3. So this, guys, should be familiar based off of the one that we did the other day. Notice I did not give you guys a mass in this problem. You're not going to need it because it's the same object. The mass will remain constant, so we're going to scribble them out. But everything else needs to be here. This 1/2, it needs to come down, times vi squared. Vi is 14. Notice I put it in parentheses. You must put it in parentheses because we don't want to take half of 14, which is 7, and then square that. Okay, we want to do 14 squared, whatever that value is, and then divide that by 2. All right, bring the plus sign down. G times hi, initial height. G is what value? 10, and hi is 30. Bring down the equal sign. Now we have to leave this the same. 1/2, okay, VF squared. This is going to stay together until like the last step or two. Plus G, which is 10, times HF, which was 6.5. Okay, from here, okay, in your calculators, you're going to make sure you put everything in correctly. Okay, so this 1 divided by 2, parentheses, 14 squared, kicks out an answer here, 98. Write them directly underneath where they need to go. Okay, so this comes out to be 98. Bring down the plus sign. 10 times 30, 300. This, again, is staying put until the very end, 1/2 VF squared. Plus 10 times 6.5, we're going to get 65. Okay, so that's your first point. That's your second point. Now, what do we want to do is we want to isolate this so it's the only thing up left on the right side. So I'm going to simplify these. I'm going to add these two together. 398. Now we're going to subtract the 65 from both sides. Okay, and we're going to come out with, I believe it's 333 equals your 1/2 VF squared. Now, to get rid of the 1/2, you have to double both sides. So this will give us this number. All right, and that is going to leave us with VF squared. To get the square root of a number, right, to get rid of the square, you have to square root it. So we square root that, which means you have to square root this. Okay, and that will come out and leave us with approximately 25.81, and it's a velocity, so we're going to be in the units of meters per second. This will be our 6th point and 7th point. 6, 7. All right, so let me zoom back out. All right, this is conservation of energy. All right, the total amount of energy here is going to equal here, assuming none is lost due to friction, which we are doing in this sense. We are assuming nothing is lost to friction. So the total amount of kinetic and potential energy of the object here, which is the left side of the equation, had to equal the side over here. Okay, and pretty much by putting the values in, all right, that's what we're going to wind up doing. You put in your given pieces of information in the correct orders here, right? You need to remember that G is equal to 10. All right, put it in, plus sign, put it in. All right, leave this to the end, bring it down. Okay, simplify the left side. Get this, all right, subtract this over. Boom. So you're left with one thing on the left and the 1/2 VF squared on the right. Double both sides to just get VF squared. Then square root it to get your final answer with the correct units. And then this last MacGyver is a conservation of momentum problem for a elastic collision. So an elastic collision, all right, the momentum before the collision is going to equal the total momentum after the collision. So these guys go here with this goes with this goes with this, and these two go with here. Now you must make sure that you are putting them in the correct spots, all right? If there is a negative sign, you must do that. So mass of the first one is 6, velocity of the first one is 7, so 6 times 7, 6, 7. Okay, plus we have M2, which is 10, and V2, which is negative 12. So 10 times negative 12. Yes, if it's negative, you must do that. Okay, now it's 6 times negative 21 plus 10 times V2 prime, or you can just write it out right here as V2. All right, that's our first point. The second point, let's simplify this out. All right, boom, 42 plus negative 120 is going to equal negative 126 plus 10 V2. Simplify the left side. All right, add these two together. You're going to get negative 78 is equal to the right side, negative 126 plus 10 V2. Okay, we want to get the 10 V2 by itself on this side. So this is our third point. So how do we get rid of a negative from one side to the other? Yep, add it. So we're going to add this 126 to both sides. And this is going to kick us out with a 48 is equal to 10 V2. You cannot subtract the 10. It is multiplied by the V2. So you have to divide both sides by 10. All right. Be like your fifth point there, fifth or sixth. We'll leave it out for now. And then, yes, so V2 will equal 4.8 meters per second. All right, so yeah, like dividing out, that would be like kind of your fifth point there. And then this will be your sixth and seventh point. All right, so we have our conservation of momentum problem with an elastic collision. It's going to be a total of 7 points. Conservation of energy here. All right, total mechanical energy before is going to equal the total mechanical after. All right, the initial mechanical energy final equals the final. So initial kinetic plus initial potential is equal to final kinetic plus final potential. Right, you kind of saw what we had done there. All right, we then have a kinematic set of equations dealing with, all right, our distance, speed, initial velocity, final velocity, acceleration, okay? Figure out what we have, what we need to solve for. And then, all right, you have forces, free body diagrams, all right, and Newton's second law all involved in this, okay? So this one was your biggest one. It's worth the most points. So you're going to, again, Fg is equal to m times g. 1, all right, 2, it tells you kind of right here, 2 points for showing work and answer for weight and friction force. So you're going to do that. 1 point each for labeling all the 4 forces that are on there. So we're doing mass times gravity, get 100, all right? First and second point, draw it down, draw it up, 4 points, boom. Take the up arrow, normal force, multiplied by the coefficient of friction. You're going to get 60. Then we take 60, all right, draw it to the left for our friction force. B is going to tell us what our applied force is. We draw it to the right. Okay, top and bottom balance out. We subtract. Whichever side is bigger is going to wind up being our spot here. And then taking that, dividing it by the mass, okay, because net force divided by mass will give us our acceleration. Acceleration does need to be in the same direction as our net force. And boom. All right, so this is what your final exam open-endeds are going to be. All right, they're going to be these problems. Multiple choice section, as I've said, is up on quizzes that I've posted. All right, make sure you do them. Make sure that you do them.